All right, very happy to be welcoming onto the podcast today, Richard Winter. Richard, thank you so much for taking the time out to talk with us today. How are you doing?
Good, thanks.
Good,
Thanks for
good.
having me on.
Absolutely. Yeah, yeah. Very excited to have this conversation with you. So, Richard, before we get into the topic of today, which is going to be modern data warehouse platforms and architectures for the cloud, would love to have a brief background about what it is that you do and also your involvement with TDWI.
Oh, sure. So I'm an independent consultant. Um, I've been doing this for about most of the time for the last 20 years. And my focus is the data platform at enterprise scale. And mainly I help customers with strategic decisions around the data platform and the data warehouse or the data lakehouse. And usually they retain me for the most important decisions, such as which platform should I use for this situation, or how do I approach the data architecture or the solution architecture for this situation. And I do this work sometimes with a small team that I put together, but focusing on the architecture and the engineering aspects of these decisions.
Well, that's great. I mean, I would assume that you're probably getting a lot of inquiries as people have over the last couple of years, especially been really looking at reworking what it is that their institution, their enterprise is currently using for those aspects there.
That's a great point. It's remarkable. There are a lot of customers who are doing a couple of things with they have a big existing data warehouse or data lake, and they want to modernize it. Often they want to move it to the cloud, or they want to look at moving it to the cloud. Um, and it's interesting because uh, doing these things at large scale in the cloud is uh, is still a very challenging undertaking for a customer, and it's fraught with risks that uh, people are not as aware of as they were 10 years ago. The cloud's sort of an interesting phenomenon in this way. 10 years ago, if you're going to build a large scale data warehouse or data lake, that meant you were going to make an upfront capital investment in a large amount of hardware. And so everyone in the organization recognized that as a big decision. Why? Because it was a commitment to spend a lot of money right at that moment.
Hmm.
And that brought a lot of strategic focus and financial focus to these decisions. But now in the cloud, the moment when you choose the platform is not always perceived as a moment, as a watershed moment, um, because there's no big spend occurring at that moment. Uh, in the minds of many executives, the big decision is, am I going to go to the cloud? And the next biggest decision is, which cloud am I going to go to?
Right.
And once they've made those two decisions, they sort of feel like the big decisions are behind them.
Right.
And but in fact, if you're going to build a big data warehouse or data lakehouse in the cloud for a major enterprise, that's a multi-billion-dollar decision. Over the next several years, you'll spend tens of millions, perhaps hundreds of millions of dollars building databases, building solutions on top of that platform.
Hmm.
And that decision, which platform do I use, is a very costly and disruptive decision to change once you've gotten downstream. And so you're sort of casting your fate at that moment. And another remarkable aspect of this is that I think many people, because of the way the cloud is sold, many people imagine that this is a low risk decision.
Mm,
The mantra of the cloud is, if you need more performance or more capacity, you don't have to worry because more is always available, right?
mhm,
It's kind of like, well, you're throwing a big wedding reception and you've made an arrangement with the caterer to pay for drinks, buy the drink.
mhm,
You don't even have to think about how many cases to order, or what your guests are going to drink,
mhm.
because you've just, the caterer will take care of everything.
Right. Yeah. Open bar.
Open bar, and that's fine.
Right.
If you can count on your guests not to drink too much of the expensive stuff,
That's
right?
right.
But if you have 300 guests and they're all drinking 50-year-old port and 100-year-old champagne, you might get a bill that's much bigger than you expected. And
Yeah.
but in the cloud, the thing about the data platform isn't really just that. It's that the different platforms are engineered and optimized for different problems. And when we buy vehicles, for example, we're aware of this. I mean, if you were trucking large quantities of goods from California to New York, you wouldn't buy a fleet of tiny sports cars to do it. You would buy or release, you would arrange to have access to semi tractor trailers or containers that could go on a freight train
Mhm.
because the volume is enormous. But many customers perceive all cloud data platforms as essentially the same in this way, and they're making their choices based on factors that are important in some situations, but they tend not to consider the factors that are important when it comes to large scale and high complexity, because those factors are not very visible.
Mhm.
So actually, I talked to a lot of customers who ask them, well, how did you choose your cloud data warehouse platform? And they might say something like, well, we had decided to go with Cloud X, and our cloud strategist felt that it would be best to just use the cloud vendor's standards in every possible situation. So, and that's actually can be a good strategy for your garden variety application development. That why if you're going to write 1,000 application programs, uh, why not standardize as much as possible and
Sure.
have everything fit together
Yeah.
easily? That kind of strategy makes a great deal of sense for that. But if the mission, if you've got 1,000 missions like that, building kind of a garden variety application solution, and you've got one where that's the equivalent of scaling Mount Everest. Well, for the Mount Everest expedition, you might want to choose, an approach that's best for the highest mountains in the world,
Mm.
not that's best for, 1,000 anthills.
Very
And,
good.
so these distinctions tend to get lost in the cloud, and they get lost partly because everything's invisible. It's invisible how big the database is. It may be invisible at the start how complex the database structure is. It may be invisible how many concurrent queries will be running. It may be invisible that your workloads on this platform, as well as routine business intelligence reporting, is going to include a heavy dose of machine learning or advanced analytics involving time series or geospatial analytics or something called path analytics I can explain in a moment. But there are lots of special analytical problems that become extremely challenging at scale. And with many of these specialized requirements, the differences between choosing platform A and choosing platform B can be enormous. And one example I use in my course and in some of my workshops is there's a published study published by a guy named Boris Sabitzer, who's he's an expert in modeling database performance, and he's been doing this for decades. So he can model the performance and cost of your database, your data warehouse or data lake on-prem or in the cloud. And he can predict, given access to your database schema, your database dimensions, and your workload, he can predict what it will cost if you put it on, Snowflake or Redshift or BigQuery or whatever you might want to use in the cloud. And he published one of these studies which I reference in my course. And in the study, so a major company came to him and they said, Boris, we have a large data warehouse on-prem. We're thinking of moving it to the cloud. We're thinking of these 3 platforms. Tell us, what's it going to cost for each of them? And so he did this, and they were going to the Amazon cloud. So he did it for the Amazon cloud. And the first one that they were thinking of, the one that actually they preferred, he projected their annual cloud charges would be $15 million a year. The second platform that they were thinking about, he predicted $12 million a year using his modeling software. The third one they were thinking of was actually kind of their third choice. Would the annual predicted cloud charges were $3 million a year.
Wow.
5 times less.
Wow.
$12 million a year difference. And that was with their current workload, which is going to grow.
Right.
So it just points up how critical this decision is.
Absolutely.
This decision, and it's also another fascinating thing is if what they were doing, this is a major company, Fortune 500 company, substantial data warehouse they've been using for years in a big way in their business. Now, if what they were doing, now this is different, there probably have been tens of thousands of data warehouses implemented in the cloud now. And it's probably less than 1% of them that would have looked like this. Most of them are departmental systems, or they're for one line of business, or they're for a medium-sized company doing routine business intelligence and reporting. A small percentage of data warehouses have these enterprise class requirements. So for all the others, the thousands of others, they could choose any platform they wanted. So they'd be right to use these sort of the more common approaches, where you say, oh, I'm going to do what my cloud vendor recommends, or I play golf with Joe, and Joe is very happy with such and such a data warehouse, so I'm going to use the same one.
Mm-hmm.
That strategy is fine if you're building a data warehouse which isn't too big, it isn't too complicated, doesn't have demanding requirements. Any one of the popular platforms will be okay. And then you can do a traditional software evaluation. You can base it on customer satisfaction, price, the services they offer, whatever it might be.
Mm-hmm.
But if you have this kind of strategic requirement where it may be make or break for your business, whether the platform delivers the cost efficiency or the performance or the availability that you really need, then you have to make an engineering based evaluation.
Mm-hmm.
And so that's what I help customers do.
That's
That was a
fantastic.
long answer, so I apologize.
No, I mean, no, that's all right. I was going to ask you why, folks might want to, engage you in these conversations, and it's very clear just by what you just outlined for everybody there. So thank you for taking us through that. It does bring a question to my mind where, as this decision is so important and with so many options, we're seeing on TDWI that, some enterprises are choosing to try a couple different cloud vendors, or even work, in portion on the cloud and have a little bit still on premises. Are you seeing that as being maybe a helpful way to go about this selection?
Yeah, so I think let me break that down. The answer is yes and yes, but it's it sort of breaks in my mind breaks into two different questions. So one question is, companies build more than one data warehouse or data lake, so might you use different platforms for different requirements? And the answer to that is yes. I think that can be. Now, I mean, you don't want to there are 8 popular platforms I cover in my course. It's not like I wouldn't recommend going eeny, meeny, miny, mo, and
Right.
choosing a different one on every data
Sure.
warehouse. I think it's a good idea to have, for your typical data warehouse or data lake requirement, to have a standard choice.
Mm-hmm.
And to pretty much as possible use the same one. If you can, it's just like business intelligence tools. Most companies really don't want to have 50 different tools. They'd like to have 2 or 3,
Mm-hmm.
And have the customer organization choose the one that fits them best. So that kind of policy with data platforms also makes sense for the, great variety of ordinary requirements. But for data platform requirements that are demanding, that's when you should do this engineering architectural based evaluation.
Mm-hmm.
And in that case, you may want to do some proof of concept or some benchmarking to help pin down which of the ones you're considering really best meets your requirements, because it can be sometimes you can predict from just an analysis or a modeling exercise, but there are situations where it's not that predictable.
Sure.
And it's well worth the effort to do a benchmark or a pilot program. We help customers do that in many cases, and there's a kind of rule of thumb I use. So for the customer's situation, we try to find out through interaction with the vendors what is the frontier of experience with respect to scale and complexity. So, for example, let's say you're building a petabyte scale data warehouse or data lake, and there are a few things that kind of characterize what you want to do. We can say what industry you're in. We can say what are some of the critical use cases you plan to implement. And you ask vendors for references for customers that look like, that have a data warehouse or data lake or lakehouse in production that looks like what I want to do.
Mm-hmm.
Doing similar things at a similar scale. So when you get back those references, if it turns out that nobody is close to your scale doing what you want to do, then you're well beyond the frontier. And if you're well beyond the frontier in any of the critical parameters, then we would recommend that you do some kind of testing to help control and manage your risk. The best kind of test is a full-scale, realistic benchmark. And the best case is where you have more than one credible vendor. And so you can test 2 or 3 of them and compare the results. So one thing is you get evidence that at least one vendor can demonstrate the capability to meet a realistic simulation of your most critical requirement. And the other thing is you get information about, let's say there's more than one who can demonstrate that capability. Then you get information about, are there big differences in the cost, in the complexity, in the the agility of the solution. And these differences can be very revealing. And as well as the conversations once you've illuminated what's going on via testing, then you can get into much deeper conversations with the vendor about what you're seeing in the behavior of the system. And we've had, remarkable experiences doing this, even with the most modern systems in the cloud. One example we saw was the customer had a pretty high volume of what we call tactical queries, short queries, simple queries that have to be answered in a very short period of time, typically a second or less. And this is queries that are generated by customers on the website, or by customers in the store, or by events in the supply chain or the factory. And so these are real-time events, and they need an immediate response. They need some kind of decision based on the data. And this customer had 1 million of these a day.
Wow. Yeah.
And that's a big number. That sets them apart. That puts them in that 1% or maybe 5%. But I mean, we also have seen situations where customers are doing 50 million a day. So it's not an extreme number, but it's a big enough number so that most data warehouse customers aren't anywhere near that number. And so they had moved they were looking at a modern platform in the cloud. And they were also doing not real-time updates, but time-sensitive updates to their data. Every minute or two, a micro batch of updates ran. It turned out now and then when one of those micro batch of updates was running, the query engine stopped.
Oh, no.
Stopped processing these tactical queries.
Jeez.
And sometimes didn't start again.
Oh.
Sometimes it just slowed down, but wasn't acceptable. And but it took seeing that actually happening to trigger the conversation with the vendor about why, and to get to the bottom of the problem. And in this case, it turned out they really didn't have an answer. So
Well, that's not good.
that wasn't the right platform for that
Right,
customer.
clearly. Yeah.
I don't think we would have learned that any other way. And we see that's not the only, we see lots of different examples of this, where I think one that's kind of underappreciated is that there are complex queries and there are complex queries. And, queries that intuitively seem fairly complicated are often handled with ease by a wide variety of platforms. Other queries become very difficult at scale. And so one example is a join query. A join is where you're matching up sets of records, typically from different tables, but anyway, sets of records to answer a question. So, we want to find the customers who have 3 children. That's one set of records. And we want to find the purchases of toys. That's another set of records. And we want to match them up.
Mhm.
So we can get some insight into which customers buy which toys. Turns out if the sets of records to be matched up are very large, then the join becomes a great deal more difficult if the database is large. It's a very tricky issue for customers because you could do very complicated joins at small scale and have no problem with them on a wide variety of platforms. You do the same joins at large scale, and it's a tremendous problem, and only a few platforms are able to do that, or able to do it cost efficiently, or able to do it fast enough, or able to do it when the join gets more complicated, or there are many variables there.
Yeah.
And so it's usually only if you have such queries in your workload, it's usually only by testing that you can sort out which platform's a good fit for you. And I keep going back to that study that Boris did because it's a question of finding the fit between the platform and the customer's requirement. Customer X could use any one of those platforms and be happy. Customer Y would spend an extra $12 million a year to choose the wrong one. So it's a very individual kind of requirement evaluation.
Yeah, sounds like it. Well, Richard, I wanted to talk a little bit about your appearance upcoming here in Nashville.
Oh, right.
And I know that you have a couple courses going on there. Can you maybe talk to the audience a little bit about what they can expect from your courses?
Yes. Thanks for asking that. So in Nashville, I'm doing 2 things. I'm at the Executive Summit. I'm teaching a management workshop, an hour and a half session with exercises. If you attend the workshop, we're going to put you to work a little bit.
That's what it's called, a workshop.
It won't hurt, but
yeah, right.
You'll have to spend a few minutes thinking about a problem and talking to some of your peers in small groups. And that workshop is about this platform selection process from a management perspective. And the workshop, the summit is focused on workloads. So the idea is it's that kind of goes back to another question you asked. You said, might a customer use different data warehouses or different platforms in different situations? It turns out, so the pieces of a data warehouse in one sense are workloads. So, business intelligence might be a workload. Reporting might be a workload. Machine learning might be a workload. Tactical query might be a workload. So if you divide your data warehouse operation up into major pieces based on the work to be done, sometimes it makes sense to actually select a different platform for a particular piece. So maybe you put a lot of your routine work on one platform, and this workload that really, has special requirements, maybe you put that on a different workload, different platform. And so the workshop is about, at a management level, how do you look at these questions? How do you recognize a situation where you might need to do something different than you otherwise would? And how do you, from a management perspective, how do you manage that process?
Yeah,
that's the management workshop. I'm also teaching a half-day course, which is aimed at senior participants in data warehousing or data lakehouse kind of projects. But this is more aimed at architects, strategists, senior technical staff, looking at more deeply into the architecture. And it's the architecture of the platforms, the kind of architectural capabilities that make a difference in these demanding situations. And also a look at the selection process, but at a somewhat more technical level.
fantastic. Well, I know that we could probably talk on and on here, Richard. I would love to continue these conversations with you, and perhaps you'll join me for another episode in the coming weeks. I would love that. But for all of those interested, you still have time to sign up for TDWI Nashville and time to sign up for Richard's courses here, as he mentioned. I think that you're going to bring a lot of value to those folks that are able to attend TDWI Nashville, and we really appreciate you as being an instructor, a vetted instructor for several years now. So thank you so much, Richard, for your time today. And I do look forward to talking to you again. So I really appreciate it. And I hope you have a good rest of your day.
Thank you. Appreciate the chance to talk with you.